Now we have this example. Find the area of the region bounded above by the line y is equal to x plus 2 and bounded below by the parabola y is equal to x squared. So again, we need to plot this equation, y is equal to x squared and y is equal to x plus 2. Now, y is equal to x squared resembles the general form of the parabola, that is x minus h squared is equal to 4ay minus k. But in this case, our h and k are both equal to 0. Since if we let h here as 0 and k as 0 as well, then we have x squared is equal to 4ay. And this gives us this equation here. So therefore, the vertex is at 0, 0. Or again, you can just try to derive the function. Then we have y prime is equal to 2x. And when y prime is equal to 0, then we have x is equal to 0. And our y is equal to 0, which are the coordinates of our vertex. And then, since our equation is in positive, y is equal to, or that is x squared is equal to y, therefore, our parabolic here, or parabolic curve is concave upward. Okay, since that's positive. So, let's try to plot this one. So, we have to plot the equation y is equal to x squared. Again, our vertex here at x equal to 0, y is equal to 0. So, therefore, we have the vertex at this point. Okay? And now, since this is a positive, so therefore, it is concave upward, or it is opening upward. So, we have, okay, so most probably, this would be our curve. That is, y is equal to x squared. Okay? Since again, it is concave upward since we have positive equation. And then we have the equation of the line, which is y is equal to x plus 2. So we need to plot this one and determine the point of intersection between this line and this curve. So let's plot. Now, how are we going to plot? We can do table. So let's try to say that if this is our x, this is our y. If we have our x here is equal to 0, that our y here is equal to x plus 2, and our x is 0, so we have y, which is equal to 2. So we have y here is 2. Now, what if our y is equal to 0? Then what would be our coordinate at x? And then let's set y here as 0, and then compute for the value of x. So we have y is equal to x plus 2. When our y is 0, our x here is equal to negative 2. So we have negative 2. I think this is the best way in plotting our line directly in our Cartesian coordinate system, by first letting our x as 0 and our y as 0, so that you will be able to determine the orientation of our line in the Cartesian system. Okay, so whether the line is directing upward or downward, and so on. So first, let's plot our line as when we have 0, x, our y is 2, so therefore the coordinate is 0, 2. So when we have x 0, our y is 2, so at this point. Okay? Then, the second coordinate is when we have x is negative 2, our y is 0, so therefore at this point. This is the y-intercept, and this is the x-intercept. So now let's plot our line by connecting the coordinates. Okay, most probably this would be the graph of our line, which is y is equal to x plus 2. And take note, there are points of intersections between our curve and our line. This point here and this point here. Okay, these 2 points. So again, we need to determine the point of intersection so that we know the limit of our area or the limit of our integration. So how are we going to determine this point of intersection? Now we have the equation of our curve and our equation and our line, which is y is equal to x plus 2 and y is equal to x squared. Now take note, at this point, the lines in our curve has a common y and a common x at this point, and the same as at this point. They have a common y and common x. So therefore, by letting our y for the line and y for the curve equal, then we have y is equal to y. That is, we have x plus 2 is equal to x squared. Okay, this is the y for the line and y for the parabola. Then we have x squared minus x minus 2 is equal to 0. This would be our quadratic equation. Now compute for the value of x using two methods. You can use the quadratic equation using x equal to negative b plus minus square root of b squared minus 4ac over 2a, wherein our a here is the coefficient of x squared, that is 1, our b the coefficient of x, that is negative 1, and c, that is negative 2. Okay? Or you can just use your calculator if you have the option in your scientific calculator. By using this quadratic formula or your calculator, then we could come up with the value of x here, which is equal to 2 and negative 1. So we have two value of x, or we have two roots since our x here is in quadratic. Okay? So therefore, having two different value of x will give us two different values of y. Okay? So let's compute for the y when our x equals to 2 using either of this equation, since again these are their common coordinates. So we can use this one or this one. Okay? But let's try to use the parabolic equation. Y is equal to x squared. So we have the value here, that is 2 squared. This gives us 4. And for the second value of x, we have negative 1 squared. This gives us 1. So therefore, the point of intersection are at 2, 4, and negative 1 and 1. Okay, so let's locate this in our graph. We have here this point of intersection, which is 2, 4. Okay, that is the point of intersection at this point. And then the coordinate of this point of intersection is negative 1, 1. So this is negative 1, 1. Okay, so we have now computed the point of intersection. We may not be encountering difficulties in identifying our limits. So we can now use integration, since our area that we need to calculate here is the area bounded by the line and the curve. So therefore, we need to calculate this area, this shaded region here. So again, in computing the area, we need to put a vertical strip in that region. And the vertical strip here has a height of y and a width of derivative of x, since our dx here is infinitely small. Now, as what you can see here, that our vertical strip lies above our x-axis. We know that if we plot the y-coordinates of any point in this parabolic curve, we always refer from the x-axis. Like for example, if we want to locate or we want to determine the y-coordinate at this point, we always refer this coordinate from our x-axis, and that is, let's say that's the y-coordinate or y distance from our x-axis. The same as with this line, okay? So if we want to determine the y-coordinate at this specific point in our line, we always measure it from the x-axis. We measure the height or the y-coordinate of this specific point from the y-axis. So let that be our y. So therefore, we can say that the height of this vertical strip, which is y, is just the difference between the y-coordinate at this point, okay, that is the y-coordinate, let's say that is y sub 2, from the x-axis and the y-coordinate at this point of our curve. Okay, let's say that's our y sub 1. So therefore, we can create a relationship that is our y here, or the height of our vertical strip, is just equal to y sub 2 minus y sub 1, in which again, our y sub 2 here, that is the y coordinates at this specific point in our line, and y sub 1 here, that is the y coordinate at this specific point in our curve. Okay, so our y here again is changing since our y is any function of x. So as our x is changing, there will be also a change in our y. Hence, we need to express our equation into a function of x. So therefore, from our general form of area, that is, we know our area here, that is the length times the width, and for the vertical strip, our length here, that is the y, and then the width of that vertical strip is dx. So we can have our area is equal to the integration of y dx. Then we sum up the area of the vertical strip within a range or a specific limit, and that limit here is from this point to this point here in our curve. Again, that's the limit, or that is the boundary, since this is the range, that is the boundary of our region from this point here up to this point. Okay, and we have our dx, so therefore our limit should be along the x-axis. If that is dy, our limit should be along the y-axis. But since this dx, our limit should be the x-coordinate. So our limit here is from -1 to 2. Okay, since we know that the x-coordinate at this point is 2, and the x-coordinate at this point is -1. So we have our limit from -1 to 2. So therefore, we have the general form of our area, that is -1 to 2. Now take note, our y is the length dx. Okay? Now, our y here is the difference in the y-coordinate of the line and the y-coordinate of the curve. So we have here y sub 2 minus y sub 1, and this is dx. Correct? That is our height, our y. Now, let's substitute, let's change our y variable here into function of x. Now, our y sub 2 touches on the line, so therefore, we need to use the equation of our line. Then we know that our y here is equal to x plus 2, that is x plus 2. Then minus our y sub 1 here touches the curve. So therefore, our y sub 1 here is the equation of the curve, and we know that our y equation of the curve, that is x squared. So therefore, our y sub 1 here is x squared, then dx. Okay? So this is the y coordinates of our line, and this one is the y coordinates of our parabola. So we can now integrate it further. Then we have x squared over 2 minus 2x minus x cubed over 3, and the limit is from -1 to 2. Then we have our area here, which is equal to 4.5 square units. So this is the area of this shaded region. So therefore, this is our answer. And then let's try to solve another example on the part 3 of this video. So I have posted the link in the description below.